Chapter 4, Example 1. For her class project, a student compared the efficiency of various coffee containers. For her study, she decided to try 4 different containers and to test each of them 8 different times. Each time she heated water to 180 degrees Fahrenheit, poured it into a container, and sealed it. After 30 minutes, she measured the temperature again and recorded the difference in temperature. Because these are temperature differences, smaller difference means that the liquid stayed hot. What can we say about the effectiveness of these 4 mugs? So, on the right-hand side, we have a table showing all this information, the 5 number summaries from her experiment. We want to compare the mugs. So if we're doing a comparison, we're describing distributions, but we're going to compare it. So we want to use comparison words. Similar to, more than, less than, greater than. We're not just listing the distributions of the Cups mugs, the Nissan mugs, the Sig mugs, and Starbucks mugs, and so on. We're comparing those. The median temperature difference for the Nissan mugs was smaller than that of the Cups mugs, and so on. So we want to describe these using comparison words. So we're going to cuss. But we're also going to compare. The temperature changes are quantitative, so numerical summaries and box plots are appropriate. So the first thing we're doing is checking a condition. Because that condition is checked, we have numerical data, we can use cuss to describe this, and we're going to use some sort of graph of numerical data. So the first thing we do is check the quantitative data condition. In this case, we have quantitative data, so it's okay to use a box plot or a histogram, stem plot, some sort of display to describe the distribution. So now at the right, I have box plots of these 4 types of cups. And what's nice about box plots is it makes really easy to compare a large amount of groups. If I did 4 histograms, it would take up the entire screen. But these box plots I can plot together on the same number line and very clearly see what's going on. I can clearly see which mug keeps coffee the warmest. The individual distribution of all coffee cups are skewed slightly to the right, which makes sense as the coffee can only cool down. The Nissan mug does the best job of keeping coffee warm with a median difference of 2 degrees Fahrenheit, the lowest of the 4 cups. Nissan cups also had the least variation in temperature loss with a range of 7 degrees of temperature loss. 75% of the Nissan tests resulted in temperature loss below the minimum loss of all other mugs tested. Sig mugs are clearly the least efficient with a median temperature loss of 14.25 degrees Fahrenheit, which is greater than the temperature loss in at least 75% of the tests of all other mugs. No tests seem to have resulted in outliers. The Nissan mug is the clear top performer and most consistent mug for keeping liquids warm. So we cussed, but I'm not just talking about one distribution. I'm not just cussing about the Nissan mugs. I'm comparing it to all of these. The individual distribution of all cups are skewed slightly to the right, so that's talking about shape right off the bat. With a box plot, I can't talk about modality, so all we can do is describe symmetry. If you look on all of them, median is the 50% line, and the boxes extend more to the right. And again, that makes sense because the lowest loss you can have is 0 degrees, but you could drop in 20 degrees temperature, 30 degrees temperature, possibly, depending on the starting temperature of the coffee. So there's far more way to go there. It makes sense that it's skewed to the right. Comparing the center. So which one does the best overall? The Nissan has the lowest median of 2%, which we said there in the second sentence. So that's describing the center and comparing it. I don't have to say the center of each type of mug, but I'm just comparing the centers by saying the Nissan mug had the lowest median of all of them. That median is below even the minimum of every other cup. Spread. Nissan cups had the least variation. The IQR looks like it's about 4.5 there, but we talk more specifically about the range, which is perfectly fine. Either measure of spread. We can see clearly there's a 7% temperature loss, and all the others had a bigger loss, so I'm comparing that. to all of them by saying the Nissan mugs have the smallest spread, the least variation of all the mugs. 75% of the Nissan tests result in temperature loss below the minimum of all others. So that's important there too. That's discussing spread. Then we want to talk on the high end as well. SIG mugs are clearly the least efficient. The median temperature is higher than the median of all the others. And the SIG mugs also have the largest range, it would appear. No tests seem to have resulted in outliers. There's no outliers there. There's no points beyond the fences. Finally, we state a conclusion. Okay, we've said the Nissan mug does best job, all that stuff. So let's actually say what is the best mug. We might want to say which is the least efficient, which is the worst mug as well. But the whole point of this analysis is to find out which mug does the better job. So we can compare everything, but if we don't state which one does the best job, we haven't really answered the question. So the final sentence, the Nissan mug is the clear top performer and most consistent mug. That tells us that's probably the one we wanted to look at. Okay, if we're looking to buy a mug, we probably want to buy that Nissan mug.